So today we are going to conduct session on battery thermal management system. So as we all know, electric vehicles are very popular nowadays, and in electric vehicle we are using lithium-ion batteries. As we all know, lithium-ion batteries are very sensitive to high temperature, heat conditions, and they are also very dedicated. So to ensure the safety of the drivers and to ensure the safety of the passengers inside the vehicle and also to ensure the safety of our vehicle and its other components, we really need to implement the battery thermal management system to maintain the thermals of the battery. So in today's session, we are going to see what is the battery thermal management system, types of battery thermal management system, and active and passive BTMS. So moving further, why BTMS? BTMS prevents accelerated capacity fade of battery by managing the heat generation inside the lithium-ion battery function in optimal temperature condition at all times. As we know that the lithium-ion batteries are having separator anode and cathode sections. So due to the internal resistance and due to the active materials inside that battery, while charging and while discharging the battery, the heat is being generated. And if we are not able to remove that heat, it will increase the capacity fade of the battery and it will reduce the life cycle of battery as well. As we all know, when the batteries are exposed to high temperature, the battery's capacity will fade earlier and the life of battery will reduce, and eventually we'll need to replace the batteries with the new ones, which will increase the cost of the batteries and even the safety might be compromised. The lithium ion cells are placed in different location in the battery pack because there are n number of cells. There are like thousands of cells inside a single electric vehicle. So it's not possible to place them all at a single location. So to distribute the weight evenly inside the electric vehicle, they are placed at different locations so that the weight distribution is managed. So as they are placed at different locations, the different location batteries will experience the different amount of heat. They will experience the different amount, different types of external environmental conditions, and there will be much difference between those cells. So to regulate that temperature, to maintain that temperature, to reduce that difference between that each cell and each and every module, so we need to implement battery thermal management system. As we are having modules, as you can see in the image, the overcharging and over discharging may lead to the battery failure. Even if we press or if we physically abuse the cell or the battery pack, it will cause an thermal runaway. It will cause an explosion. Even if there is high charging and high discharging of the if we are charging it over the limit and under the we are discharging it over the limits, it may cause the battery pack failure. And as we can see in the image, the even if one cell has been damaged or one cell caused the fire, it will lead other cells to cause the same kind of troubles in that, and eventually it will cause the thermal runaway. I hope you're getting. Are you with me? Yes. Am I audible?
Yes, you are audible.
So exposing the lithium ion batteries to the extreme condition can have fatal consequences and operating it at very high temperature can cause the thermal runaway. As we have seen in earlier case, if we are exposing the batteries, lithium-ion batteries, to the extreme conditions, it may cause the thermal runaway. In case of NMC batteries, it may also lead to the fire, as we have seen the many cases earlier in electric vehicles, that the electric vehicles are causing getting caught in fire, or they are exploding due to the heavy high temperatures. This certain accidents happen mostly in the summer, because in summer what happens, we if I am parking my electric vehicle at a very sunny day in the outside area, and I am charging it there only in the in the sunny area parking, right? So what will happen, the temperature, due to the environmental conditions, due to the external condition, due to the ambient temperature, the temperature inside that battery pack will increase. Even simultaneously I am trying to charge that battery pack, right? So due to the charging also, the internal temperature of battery pack will increase, so that both temperatures will get add on. And after the charging, I am trying to I am traveling from one place to another place, so it will also, so I am trying to discharge it as soon as I have charged it inside the heated area, right? Now I have charged the battery pack, I am trying to discharge that battery pack, and even I am traveling in the sunny area in the on the sunny day. So what will happen, all that temperature will get add up, and temperature will rise so much that it will cause fire. So that's why before 2 to 3 years we were hearing lots of lots of accidents, that electric vehicle are getting caught in fire, or the battery packs are exploding inside the electric vehicle. But nowadays the industries, the battery manufacturers, and even the vehicle manufacturers are have developed the good thermal management system, and even the battery management system has been implemented for that cases. The battery management system is whole new topic. We will discuss it on some other day. To be concentrating on battery thermal management system, the electric vehicle manufacturers has really done well, so that the such accidents doesn't take place. Moving further to the topic, the battery thermal management system is component in the battery pack that is responsible for ensuring that lithium-ion cells operate under the optimum temperature conditions, which is specified by the lithium-ion cell manufacturer. There are some active materials within the lithium-ion cell, right, which are disclosed by manufacturer, what kind of materials are there, or in what quantity, or the R&D which has done by the manufacturer. He gives us an optimum temperature condition, right? So on the graph, as we can see, the optimum temperature condition for this battery is from 0 to 40 degrees Celsius. But as we can see in image, as we can see, between 20 degree to 40 degree, the battery's performance is very high. But as we exceed the temperature beyond 40 degrees Celsius, the performance of battery is decreasing, right? And if I am reducing, if I am cooling the temperature, if I am going beyond the 20 degrees Celsius towards the 0 degrees Celsius, towards the minus 20 degrees Celsius in the colder region, right? Then also the battery's performance is decreasing. This happens because as I'm increasing the temperature, the active materials inside the battery pack may lead to burnout, right? Because the lithium is very unstable material. It's very explosive material. So if I am increasing temperature beyond 40 degrees Celsius or 50 degrees Celsius, it will eventually decrease the performance, as well it may cause the thermal runaway, right? And there is, if you study deep to inside the lithium ion batteries, there is separator. The separator is nothing but it divides the anode and cathode. Okay, so if that separator melts down, below the beyond the certain temperature conditions. If I try to increase the temperature levels of that particular cell, the separator will get melt down, and it will eventually lead to the short circuit inside that anode and cathode. So we all know what happens after the short circuit, right? After the short circuit happens inside that cell, it will get exploded. First, it will like give out some smoke. After that, it will give you the hissing noise, and after that, it will explode. It will firecrackers, right? Like fireworks. It will throw out the flames. So what is effect of charging? What is effect of temperature on charging and discharging? As we can see in the image, as we can see here, when the operating temperature is 15 degrees Celsius to 35 degrees Celsius, we are getting rated power as this cell or the manufacturer has designed it, right? We are getting the optimum rated power, right? But if the temperature is going beyond 35 degrees Celsius, the degradation has been started, as we can see in the image. As the degradation starts, as the lower of the rated power goes down, we are getting less performance. And as we can see here, if the temperature go below the 15 degrees Celsius, the electrochemistry inside that cell, inside lithium ion cells, there is electrolyte. Electrolyte is nothing but it is an medium through which the lithium ions and electrons are passing, right? It is like medium through which that ions and electrons are passing. So if the temperature goes below the 15 degrees Celsius, that electrolyte will get solidified. And if it gets solidified, it will be very hard to move that electrons and lithium ions. So we need to keep that temperature. We need to keep that electrolyte in like liquid form, in semi-liquid form. If it solidify, it will go in sluggish electrochemistry, and it will reduce the rated power capacity. And if the temperature goes beyond 35 degrees Celsius, it will increase the movement of that lithium ions and electrons. They will get highly unstable, which will lead to thermal runaway. System functions. So what are the main functions of battery thermal management system? So as we can see, cooling, heating, insulation, and ventilation. These are the main functions of battery thermal management system. Cooling, due to inefficiency, battery cell will not only generate electricity but also heat. This heat should be moved from the battery pack when the battery temperature reaches to the optimum temperature level, or even in advance. All right, as we have seen earlier, we need to do when we are charging and discharging the battery packs, or even if we are parking our electric vehicle inside on the sunny day, and after that we are trying to use our electric vehicle. So what happens? It will generate heat. So we need something to remove that heat from that battery pack, so that our battery pack remains into optimum temperature levels. Even in our internal combustion engine, in summers, what happens? There is lots of heat generated, and we are having like radiator, right? So what does an radiator do? It cools out the engine. And if the temperature increases beyond certain level, the engine's performance will decrease, and even it will come to the maintenance sooner, right? So what we need to do, same in electric vehicle, right? So we need to cool that lithium ion batteries so that it will remain in the optimum temperature levels, right? So other function is heating. In cold climate, the battery pack temperature probably falls below the lower temperature limits. Hence, the heating function such as heater is required to assist the battery pack to reach the proper temperature ranges in short time, right? So as I have told you, the lithium ion electrolyte is like an semi-liquid material, right? So that the lithium ions and electrons can travel from anode to cathode and vice versa. So in lower temperatures, if that electrolyte gets solidified, there will be no medium. They can't travel from that solidified material, solidified electrolyte. So we need to keep that electrolyte and we need to keep that active materials which are present inside that lithium ion batteries up in the proper phase, right? So we need to heat that lithium ion batteries as per our requirements so that it will remain in optimum temperature and the electrolyte will remain in proper phase and the lithium ions and electrons can travel efficiently. Another function is insulation. In extreme cold or hot weather, the temperature difference between inside and outside of the battery pack is much larger than that the mild weather. Battery temperature will thus fall or rise sooner out of the proper temperature range. So what is an insulation? What insulation do? Insulation is nothing but it resists the temperature exchange, right? It resists the heat exchange inside that material. So if I am parking my electric vehicle in the sunny day and there is lots of heat outside, right? So what will this insulation do? It won't let the heat enter to my battery pack. Or even if I am parking my electric vehicle in extreme cold conditions like Kashmir or like any other cold conditions, if I am using my electric vehicle there, so what will happen? There are very extreme cold temperatures outside, right, in the environmental condition. But it should not enter to my electric vehicle's battery pack. So to insulate them, the battery thermal management provides a system to insulate this temperature variations so that this temperature difference remains shorter. And if this temperature difference remains shorter, the heating and cooling method will work more efficiently. If insulation is not there, the heating and cooling method will be not able to work as we need, right? Because if there is a very extreme cold conditions outside and I am trying to heat my battery pack with the help of heater or any other means, but what will happen after some time, again the outer colder conditions will cool down my battery pack. So there will be lots of losses there. The efficiency will really reduce. So the insulation is the best way to keep our battery pack at the proper temperature levels. Another function of battery thermal management system is ventilation. Ventilation is required to exhaust the hazardous gas within the battery pack. In some systems such as air system, this function is combined with cooling and heating function. So as we all know, the lithium ion battery packs are made up of active materials, and while charging and discharging them, they may release some gases. So it's very important to release that gases outside our vehicles or outside our battery pack. So to do this, the ventilation system is being implemented inside the electric vehicles battery pack so that the hazardous gases, whatever is being created while the discharging and charging discharging, this should be exhausted out of the vehicle so that there is not any harmful gases remains inside that electric vehicle which may be inhaled by the passengers inside the vehicle, or it may lead to some burnouts, or even that hazardous gas may be flammable, right? So if anything wrong happens, so it might get exploded. So it is very important to ventilate that hazardous gases. So now how these things work? What are the types of BTMS? So there are mainly three types of battery thermal management system. Active thermal management.
Can you reshare the PPT? Like stop
Is it not?
presenting and then reshare. It is visible, but the pin by default is removed.
Okay, okay, okay. Yeah. Kindly confirm, is it visible now properly?
Yes, it is visible.
Okay, that's great. Okay, so the type of BTMS, right? Battery thermal management system are mainly of three types: active thermal management system, passive, and hybrid. The active, there are again two subtypes inside that: air and liquid. In passive, there is PCM. PCM is nothing but phase change material with heat pipe, and hybrid is combination of two types, active and passive, like PCM with air, PCM with liquid, and PCM with heat pumps. So now what is active BTMS? Active BTMS are based on liquid or forced air centered at that use of energy equipments like pumps, compressor, and fans to push the coolant flow through the battery. So what we are doing here, we are using pumps, compressor, fans, and the airflow to remove the heat from that battery pack, right? So as we can see in this next slide, these are the passive air cooling and heating, active air cooling and heating. Battery thermal management system, air cooling system, serve the function of passively cooling of a battery pack by allowing the air to pass through the module, right? So what happens? The battery pack, the air is blown on the battery pack. Okay, so we know that if I'm blowing the air on that battery pack, and if it is heated, what will happen? That air will absorb the heat from the battery pack, and eventually the battery pack will get cooled down, and that heated air will be exhausted outside the electric vehicle. The system of air cooling can be classified as natural convection and forced convection, or artificial, right? Depends on like if we can use fan there, or we can use direct natural cooling also. So as we can see, so see, this is what happens in passive air cooling. This is the battery pack here, right? So I may place fan here also, or even after the battery pack, right? I can, what I will do, on the battery packs module, I will directly throw the air. Okay, I will direct blow the air on the battery pack, and that air will absorb the heat from that battery pack, and it will be released from the exhaust. But in passive air cooling, what happens here? From the outside air is going to the cabin. Okay, cabin means where the passengers are sitting, right? So what happens there? If we are turning on our AC, the outside air is going into cabin first, and from cabin the battery pack is absorbing that air, means that air is been thrown to the battery pack, and from that battery pack it's again given to the exhaust. It will be thrown out, or in case of heating, that heated air will be again going to the cabin air, or it will be again going to the battery pack, and it will increase. The cycle will go on there, right? It's like a cycle. So there the temperature will increase. And if now I need to reduce the temperature, I'll throw that heated air from the exhaust outside. What happens in active air cooling? I'm giving the air to the cabin, right? And even from the AC, right? And that air is going to the battery pack. From battery pack, the fan will extract that air. It will create the pressure. That pressurized air will again go to the cabin, right? Again to the heater or the evaporator cores. And again, it will go to the battery pack. It will again return. It will again go to the battery pack. So it's also like an cycle. So it's mainly used in mainly used in Toyota, right? So circulate the cold air through the lithium ion cells. So now what happens in liquid cooling? As we can see, the liquid cooling is very simple in design and the efficiency is maintained because the temperatures can be extracted very easily with the help of liquids, because the liquid can store the temperature. The latent heat capacity of the liquids are high, so that the heat transfer can be occurred easily. So as we can see in this passive cooling system, here we are having this cycle. This circuit is there. From here, I am giving the air or the liquid to the battery pack, and this pump will cause the pressure, right? This pump will pump the air or liquid through this circuit and to the battery pack. And as we can see here, this is an exchanger, right? This is an radiator, like an heat exchanger. So this this warm air or warm water will run through this radiator, and from this radiator, the heat will be extracted with the help of fan, as we can see. And what happens in active liquid cooling? There is two circuits. One is primary and another is secondary. So this one and this one is kind of same, but here instead of using the radiator and fan, here we are using the refrigerant. Okay, it's like an air condition or like kind of refrigerant is being used here. So whatever the warm air and warm liquid is passing through this primary circuit, this will be cooled down with this secondary circuit with the help of evaporator and condenser. The refrigerant will move from this circuit, and this will be the this will also be used for the cabin cooling also. This can be also used for cabin cooling, right? The AC, whatever AC we are using for the cabin cooling, it may be also used for this battery pack cooling. So even here are some disadvantages, because the complexity is liquid based. If we are talking about the liquid based system, it will occupy volume, and also it will be the complex. And in case of we are using the liquid based system, there might be some leakage problems, and there are low efficiency in achieving temperatures between the cells. To maintain the temperature differences between cells, in this case, is low efficient. Now, what is immersion cooling? So immersion cooling is nothing but the lithium ion batteries are being submerged into the non-conductive dielectric fluid, right? The dielectric fluid is very good conductor of very good conductor of heat, and very bad conductor of electricity. So what happens? This lithium ions are directly submerged, directly dipped into this liquid, this non-conductive dielectric fluid, and that liquid is passed through the cooling circuit, right? So as we can see, these are the lithium ion cells, and we have submerged these batteries, these cells, inside the liquid, and this is the outer casing, so that there won't be any leakage. There is also a pressure valve if the temperature rises, or as we all know that whenever the liquid is being heated or any material is heated, it it gets expanded, right? So if any expansion occurs or any air pressure occurs, so this pressure wall is given here to release the extra pressure. So when this liquid is heated, this lithium ion cells will give the heat to the liquid, right? So we need to absorb the heat from that liquid. So what we can do here, we'll create another circuit here, right? So this is the cooling circuit here. So this liquid will pass through this cooling circuit. It will get cooled. This liquid will go into the reservoir where we are storing the extra liquid so that it can be used in case of any leakage or in case of any expansions. And there is pump to force this water, this cool water, to the module, right? And even in case we need to heat this lithium ion cells, the heater is also been provided. Okay, so what does this heater do? This heater will increase the temperature whenever required. Whenever the battery management system will give the whenever the temperature sensors will give the signals to this heating and cooling system, they will act accordingly. This dielectric fuels mainly includes of hydrocarbon oils, silicon oils, and fluorinated hydrocarbons. Passive BTMS. Now, passive BTMS is an alternative to active BTMS, and it will overcome their disadvantages. The mainly two solutions of passive BTMS is phase change material and heat pipes. So what is phase change material? Phase change material will go through the multiple physical phase changes when they are heated, right? It will turn from solid to liquid or vice versa. PCM is generally a block of solid material, often based on wax and graphite, which is machined or molded with locations to insert the cells. As the cell heat up, the PCM absorbs the heat and disperse it throughout all PCMs, causing the material soften or melt. So this PCM, which is known as phase change material, okay? So this phase change material will absorb the heat. The lithium ions will be dipped or submerged into this PCM. It's mainly made up of wax and graphite, okay? So what happens when it's heated? It will turn into liquid, right? It will change its phase from solid to liquid. And when when the lithium ions will cool down, it will again turn from liquid to solid. So as we can see here, the cell temperature and the time, the melting point. As the temperature increases, heating without PCM, the temperature remains constant during the melting, right? The temperature remains constant during the melting. But as the time goes on and as the cell temperature is increasing, the whatever the phase change is there, the melting point, as you can see, the melting point is also increasing. So what happens? This phase change material will turn from solid to liquid when it is heated, and when that heat transfer is done, when we are removing that heat from that liquid, so it will again turn into solid. So PCM is very good alternative because PCM is an non-conductive, right? And there are very less chances, there are like negligible, no chances of any kind of leakage as there were in liquid cooling system. And it is very efficient also. And this can also be combined with other battery thermal management system like liquid cooling, air cooling to manage the battery's core temperature. Because when we are talking about PCM, it's directly in contact with this those lithium ion cells, so that the heat is extracted properly. Next is heat pipe cooling, right? It's passive cooling system, which is basically a sealed tube filled with refrigerant, and it absorbs heat by vaporizing the refrigerant from the hot side, and it removes the heat into surrounding by condensing the refrigerant back to the liquid form. So as we can see here, these are the lithium ions. These lithium ion cells are placed such that there is some gap between those cells, right? These are the cylindrical cells, and obviously the gap will be there in cylindrical cells, right? So from that gap, what is happening here? They are placing aluminum sleeves so that the aluminum sleeves will uh, capture the more area, so that the heat transfer will be good, right? And from aluminum sleeves, the heat pipes are connected, so that the heat will be absorbed from this heat pipe. So these heat pipes are mainly made up of copper, right? So these heat pipes are mainly made up of copper. So heat from this lithium ion will be transferred to this aluminum sleeve, and from this aluminum sleeve, the heat will be transferred to the heat pipes, and there will be air or refrigerant flowing through those heat pipes, and it will absorb that heat properly. And we all know that copper is a very good conductor of heat, even electricity, but we are talking about heat here. The copper is very good conductor of heat. So what happens? It will extract the heat from those cells, and it will go to this cold plate area, right? So this heat will be extracted through this inlet and outlet. The air or the refrigerant or the liquid will be flowing through this block, and from this block we can remove the heat. Now, how does hybrid BTMS works? So as we can see in the image, the hybrid BTMS can be coupled with air or liquid cooling method. Heat pipes are coupled with air or liquid cooling. As we can see, what's happening here? These are the lithium ion cells. Okay. I hope you can see the cursor. These are the lithium ion cells, and there the heat pipes are being placed, right? And what's happening here? We are using the liquid cooling here, right? So the liquid will be flowing from this inlet. It will be extracting the heat from these heat pipes, and the heated liquid will be moving from this outlet. And that heated liquid will be cooled down with the help of external circuit like radiator. Same in this case, what's happening here? These are the battery packs. This is the battery pack modules, and the heat pipe is been revolving here, right? The heat pipe has been placed here, and with the help of this fan, the heat from this heat pipe is been extracted, right? So here we have coupled the heat pipes with the active air cooling method. Same the examples are here. These battery packs, these cells, here we have connected this aluminum fins. Here you can see the ultra thin micro heat pipes, right? So ultra thin micro heat pipes are extracting the heat from these cells and giving to the aluminum fin. And from this aluminum fin, we can extract the heat, right, with the help of fan. In this case, the PCM phase change material has been coupled with the air or liquid cooling, right? So as we can see here, these are the cells, and there is the phase change material here. And the cells, the heat from the cells will be extracted from this phase change material. This phase change material will turn from solid to liquid when the temperature rises. And when the temperature rises, when it's in liquid form, the heat from that phase change material will be removed with the help of this aluminum pipes, right? And from this aluminum pipes, heat will be removed from air or liquid. The liquid or air will be flowing from this aluminum pipes, or even the copper pipes can be used here. So as we can see in this image, this has in this form the PCM is been placed with the help of blocks, right? And we can flow the air or the water to remove the heat. So in this case, PCM has been coupled with heat pipes and active cooling. So here we have combined three types of cooling methods, right? Phase change material, heat pipes, and active cooling like fan, right? So as we can see here, this is the module, right? So here battery packs are there. Here are the battery modules, and the heat pipes are placed between these modules, right? As we can see, the heat pipes are placed between this module. The heat from this battery will be given to the heat pipes, right? And this heat pipes will be submerged into the phase change material. Even we can see here, there are the heat pipes between these modules, and they are totally submerged into the phase change material. And from this phase change material, the heat will be transferred to the fins. There might be the aluminum fins or copper fins. So from these fins, the heat will be removed from air, right? So this fan will blow the air on these fins, and the heat will be extracted, right? Even we can use the liquid cooling method here. We can use some kind of like flowing liquid like glycol or any other coolant, so that we can remove the heat from these fins. So this method is very efficient. It might seems to be complex, or obviously it will be very costly, but it's like very highly efficient, and it will respond. It responds to the heat changes very quickly, right? So here is a short differentiation between the between the cooling methods, right? So if we are talking about air cooling methods, it's suitable for all types. Even it's simple, cheap, and even we can use it for the battery heating in the winters. But if we talk about the disadvantages, the heat transfer of the air cooling is very ineffective, right? Because the air we are flowing, it's moving with some speed, right? So the heat transfer from that cell is very inefficient. Again, the high space requirement is there. Again, the additional weight problems. Again, the if we are flowing the air, there is the noise disturbance, right? If we are talking about the refrigerant cooling, the heat transfer rates are high. Again, it allows the battery to handle a larger plus powers, because if the heat is removed very easily, efficiently, so the battery can be used at the extreme conditions also. Again, we can extract the high amount of power from that battery pack without any losses. Again, the effectiveness of temperature uniformity is good. Again, the low space is required, right? Because the refrigerant can flow from very small pipes also, so that the heat transfers are good. If we talk about the disadvantage of refrigerant cooling, so refrigerant cooling does not provide us battery warming, right? So if we need to heat out our battery pack in the colder conditions, we can't use this method. Again, the electric shortage due to liquid leakage. So if the refrigerant is been leaked, it might cause the electrical short circuit or uh, again the if the refrigerant is been leaked, it's very hard to repair it. The maintenance is very hard. We need to switch off all the things. We need to it's very a headache to repair those fins of the refrigerant coolings. Now, if we are talking about cooling and heating, the the transfer rate of heat is very high in this case. Again, it allows the battery to handle the larger plus powers because the heat transfers are good. We can expose our battery to the extreme conditions. We can expose our battery for even for fast charging and fast discharging methods. We can extract high amount of power for greater torque and greater speed capabilities. And again, the effective temperature uniformity is greater in this case. If we talk about disadvantage, it's the most costliest method. It's very expensive because the whatever the material and whatever the things we are using in this method, it's very complex and very costly. Again, the electric shortage may be due to the liquid leakage, right, and the high space requirement. So these are some disadvantage and advantages of the cooling methods. So to remove these advantages and disadvantages, as we have seen earlier, we are trying to couple the different types of cooling methods with each others, so that the advantage of one cooling method can be comply with another disadvantage of cooling method, right? So they can balance out and they can give us good efficiency in the world of electric vehicle thermal management.
Your voice is not audible. I think there is some network issue. Please wait. Hmm. Trainer is joining in 2 minutes. Please wait.
Yeah. Very sorry for the network disconnection. Uh, I'm sharing the PPT again. So we were on the video, right? Am I audible? Yes. Okay. So so we are going to see this small video on the battery thermal management system. Okay.
Yes, sir.
Right. So this was all for today. The audience is open for any kind of questions uh, we can discuss. Yes.
If you have any query, please ask.
Uh, Hello, this side, Dr. 𝑭𝒓𝒆𝒆. Are you able to hear me?
Yes, yes, sir. Yes.
Yeah. So, what kind of dielectric is required if the cooling is to be done? Grade or you see, you told no, it can be submerged into that.
Uh, yes, sir. The dielectric should be non-conductive material as we are talking about the high voltage inside the electric vehicle's battery pack. So we need to be very accurate and very precise so that there shouldn't be any kind of short circuit there because we are talking about 600 to 700 volts with the
Yeah, but
lots of high
you see,
amperage.
the heat absorption is there, then it's a density and other things also to be just seen, no? How much heat it can absorb.
Right, right.
Yeah.
So we
That is
need to
what my
consider all those
question is.
factors. Right.
Yeah.
So we need to consider all those factors, not just only the density of the material, but we need to also see what is the capacity of that battery pack, what is at what location that electric vehicle is being used. Like it's like an India or like some colder countries like North America or like it's like any other countries.
Their
So we
temperature
need
conditions are different.
right, right. Right, the temperature conditions are different. Even the we need to see what are the driving factors, what are the main use of that electric vehicle. So it's like it comes under the sports car or it comes under the normal utility vehicle, or it comes under the passenger vehicle, right? So we need to consider all those factors. We need to also consider what are the what are the ratings of the motor is, what is the capacity of the controller is. So all these things are been researched, and the thermal management system is being developed.
You also told that you see lithium-ion batteries, it can attain certain pressure. So, is there any kind of you see handbook or anything that how much pressure it can exert? You see, if heating is there, definitely volume can increase inside, and if temperature is not just controlled. So, how much after that it can burst? It can have damage also if overheating is done. Is there any handbook or is there any relation about the batteries having this capacity need to be can have this much pressure and this?
Yes, sir, absolutely. Whenever the manufacturer is manufacturing the battery, so he is like designing whole system, whole casing, even the active materials which are present within the batteries, they are researched very properly, very accurately. So while doing all those things, they are creating an like kind of manual or like kind of what we can say, the booklet, so that the whatever the usage is being done of those batteries, so that the manufacturer and the user can understand well how this battery has been designed and what temperature or what pressure levels it can sustain, so that there is a very safe use of that battery has been made, so that there is no harm to any kind of user there.
All right.
Right. Yes, any other questions or queries? I hope I've cleared the questions.
Yeah. From my side, it is over. Anyone wants to?
Sir, can we obtain the PPT, sir, so that not to refer it again?
Yeah, sure. The team will share the PPT.
Yes, sir. Thanks. Sir, webinar regarding designing of this electric battery pack would be more useful, I feel. If you can kindly arrange it, it would be of great use for the students, sir.
Designing of battery pack.
Yes, sir.
Designing of battery thermal management system. Yes, can you please confirm designing of battery pack or designing of battery thermal management system?
Designing of battery pack.
Okay.
Battery pack is somewhat easier, sir, but battery thermal system would be much better, sir, if you can provide it.
Hello?
It will be, if the sessions are there, it will be shared by our team.
Yes, sir. Along with the parameters and all, like how to you can actually provide us a case study.
Okay.
That would help us a lot in order to learn. That's nice.
Absolutely. Yes. I think someone were trying to ask something. Yes. Any questions?
Hello?
Yes. Hello.
Sir, did we get any feedback form for this in order to obtain the certificate?
Yes, it will be shared by our team.
Okay, sir.
Yeah, it's in the chat box. You can go through the feedback link. Okay. Okay, I think there are no further questions on this session today. So with this and this today's session, I hope the session will be prove valuable, and I hope that I have delivered the session properly. With this, I take the leave all to the team members. Thank you.
Okay, thank you. And
That
thanks,
was
learners, for
excellent
attending the
session.
webinar.
Thank you very much. Very good.
Yeah, okay. Thanks, learners, for attending the webinar. I hope this webinar helped you out to upskill your learning and skills. I would like to take the opportunity to introduce our company, ISIE India products and services that we offer in EV technology with small video. So please, learners, have a look.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. Like pay after placement, no cost EMI, placement assurance, global wide certification by automotive National Skill Development Corporation, NSDC, Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC, Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSGC and ASGC, Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSGC, Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consists of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Very thanks, learners, for watching the video patiently. So, any of you want to enroll in the course, kindly send us inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future with an exciting offers too. Thank you so much.
Ma'am, can we leave?
Yes.
And so, how can we get certificate in the online or offline?
You will get on your mail.
Okay, thank you, sir.
Feedbacks, we
The
have,
feedback link is not working.
the link is there, I have already filled it. I think mail will come.
So the
Is it?
feedback is going to the Google Maps, sir. Finally, we done.
Yeah.
Yes, it will be redirected to the Google Maps. Then you have to submit a review on ISIEINDIA charging career.
Oh, okay, sir. Thank you.